In this video, I will show you how to find expected value and standard deviation by hand. In the next video, I will show you how to do it in Staplet, but before you skip ahead straight to using technology, at least stick around for expected value because very common errors come up because while this does represent a mean, it is a little different from the mean that we're used to in terms of what it represents. So these are the formulas. We'll kind of tackle them one by one as we go through these pieces, but let's start off by talking about expected value. So the notation that we use, and this symbol right here, that is our symbol mu, which represents a population mean. And why we're using population notation here is because we do have all of the information in this table. Like I was talking about in the last video, we should be covering all of the possibilities, and that's why the probabilities add up to 1. They're adding up to 100%, which means we have everything in that table there. So that's why with each of these, you'll see that population notation coming through here with this is our symbol sigma to represent population standard deviation. And we'll talk about variance a little bit. It's more a nice stepping stone to get to standard deviation, but we'll talk about that too. Okay, expected value, which is our mean. A new notation that we'll be using is this E of X. So some of this notation, like we've been using P of X, so that's like our probability of X. And this would be read as our expected value of X. So expected value of X, which is our random variable. And then we would have variance of X, standard deviation of X with this new notation that we're working with here. Okay, as a reminder, this big symbol here, this is actually also called sigma. This is capital sigma, and that's lowercase sigma for standard deviation. Yeah, apparently, yeah. In the Greek alphabet, we have capital and lowercase there as well. But most importantly, what you should think of when you see this symbol is add. We want to add things up when we see that symbol. So what this is telling me is take our value for X, take our value for P of X, multiply them together, and then add up as we go across the table. So we're going to use our cups of coffee here. Going back to this table, we have our X value and our probability. So what I want to do is multiply those together. And then that sigma symbol is telling me to add. And then I move on to the next ones. And then I add, move on to the next, add, move on to the next, so on and so forth. So let's go ahead and write that out. And then we'll talk about interpreting it and all that good stuff. Okay, so for this scenario, E of X, using that table on that last page, we'll have 30 times 0.05 plus 36 times 0.2 plus 42 times 0.25 plus 48 times 0.15 plus 60 times 0.35. Okay, and then where we would go from there is plug it into a calculator. Any old calculator will do. I like to use that Desmo Scientific calculator, and that's going to give us 47.4. So what I can say is the cafe can expect to sell about 47 cups of coffee in a day. Okay, the piece I wanted to get to here that kind of shows how this calculation differs from how we usually calculate mean is I'm actually even going to do a little side work. This is not what we should be doing with this problem. I really want to emphasize that, but I want us to take a look at how we usually calculate mean. So something that I see come up here is the question will ask for the average or the mean, and then we have our probability distribution. And what I see occur is students will add up the cups of coffee and divide by 5. And there's two issues with that. One pretty clear issue is that that's completely ignoring these probabilities, and that's very important information. And what's happening there is the probabilities are important because it's giving different weight to different values. So that's our second issue, is we actually want a weighted average when we're calculating an average of this table. So what that means is that when we add these up and divide by the number of them, we're treating them equally. But what we can see here is this outcome of 30 only has a 5% chance of occurring, while 60 has a 35% chance of occurring. So this means that 30 shouldn't be as equally weighted into the average as 60 should be. 60 should be emphasized because that has the highest probability of occurring. Then 42, then 36, then 48, then 30. So that's why we're including the probability as part of the calculation, is it's essentially scaling our values. That 30 is being scaled by 5%, and that 60 is being scaled by 0.35. So how we usually calculate mean is we would add them up and then divide by how many there are. Now bear with me for just a second, because what this really translates to is like taking a fifth of 30 plus taking a fifth of 36 plus taking a fifth. In fact, I'm going to do like a little ... thing. But we're taking a fifth of each, which would be the same as 0.2 times each of those. And do you see how that starts to look like our calculation from up above? It's just that each of them would have the same probability of 20% occurring, which is not true. So really the two calculations come from the same place. We just don't calculate our usual average like this because it's pretty boring when it's exactly the same and we could just divide it all by the same number. But it is at the heart kind of the same. But here we're adjusting those probabilities based on the weighted values. So that's just something I wanted to emphasize, is that this is a weighted average that we're calculating here. Whereas when we calculate the mean with our usual formula that we learned a week or two ago, that isn't weighting value. They're equally weighted, so it's just the average there. All right, I'll go ahead and stop that video here, and then we'll go on to the standard deviation.